Hello, my name is Ali, and I am a mining engineer at Costmine Intelligence. I would like to introduce you to one of our products, SHERPA Underground, a powerful tool for cost estimation. Depending on the information available for your project, SHERPA Underground can be used for rough order of magnitude estimates, preliminary economic assessments, pre-feasibility studies, and feasibility studies. Since the 1980s, our team has been collecting engineering data from mines to develop the powerful algorithm at the heart of SHERPA. In the early stages of exploration, it's common to lack complete information about your project. SHERPA's algorithm helps estimate crucial parameters you might be missing. SHERPA is flexible. You can always edit the estimated parameters in the model to better fit your project. Its database, updated annually, includes over 300 equipment prices, supply prices, wages, and salaries. SHERPA's output provides detailed estimates of initial capital costs, sustainable capital costs, and operating costs. Suppose you have a potential ore deposit that can be mined through cut and fill and shrinkage mining methods. The following information is required to create a cost model. Total resources, which is 8,200,000 tons. Working hours are 10 hours per shift, 2 shifts per day, and 320 days per year. Material is transferred to the surface through an adit via rear dump trucks. The vein deposit has a 75-degree dip and is 4,000 feet long, 12 feet wide, and 2,000 feet high. The vertical distance to the surface and horizontal distance to the surface are 800 feet and 4,500 feet, respectively. This mine has 3 sequences and a total life of 22 years, including a 3-year pre-production period. The first sequence starts in the 3rd year and combines cut and fill with 80% and shrinkage with 20% mining methods. This phase continues until the end of the 5th year. The second sequence begins in the 6th year with a mix of 60% cut and fill and 40% shrinkage methods. The last sequence exclusively uses the cut and fill method. In this mining operation, the primary stoping method is cut and fill, employing a slusher for muck collection and a rear dump truck for haulage to the transfer point. The secondary stoping method involves a scoop tram, the LHD, for muck collection and haulage to the transfer point. To create a cost model for this project in SHERPA, click on Add Project. Name the project Demo. Select the measuring system, either imperial or metric, and the database year. The database includes equipment and supplies prices, wages, and salaries. You can return to this page to change the database year and measuring system, rename your project, or add a description. Click on Add Project again to add this project to your main folder. As you can see, the demo project has been created. To open it, click on the Setup project. SHERPA Underground has 4 main sections: data entry, equipment, engineering, and report. The first 2 pages under data entry are mine operating specification and deposit characteristics. You only need to fill out these 2 pages to create your model. The rest of the information will be generated using the SHERPA algorithm. To start, enter the first sequence information on the mine operating specification page. After entering the data, click on Save and then Add Sequence to create a new phase. Repeat the process to create the second and third phase. Next, enter the information on the deposit characteristics page. Note that the deposit characteristics are generated for the other sequences and are identical to the data entered for the first sequence. The rest of the information is generated by the SHERPA algorithm, but you can always adjust them to fit your project. For example, in the ore and waste characteristics section, the suggested compressive strength for ore is 10,000 psi. You can overwrite this value and change it to 12,000 psi. Note that changes applied to the first sequence will not necessarily apply to the rest of the sequences. In the second sequence, the default compressive strength for the ore is still 10,000 psi, which you can change to 9,000 psi. Under the data entry section, you can adjust the stope size, create an adit, inclines, declines, shaft, drits, crosscuts, draw points, access raises or passes, vent raises, add rock support to your developments, define new openings, and adjust your supply prices, wages, and salaries. The next main section is equipment. Under this section, you can change your drilling and blasting equipment with a specific bit diameter for different sections of your mine. Change the type and size of equipment for mucking and hauling. Select your backfilling method, including the required amount of materials to be pumped for backfilling. Change your primary ventilation fans and the required air volume per worker. Select drainage freshwater pumps and pipe sizes. Change your ancillary equipment sizes such as ANFO trucks, service vehicles, and shot critters. The next main section is engineering. Under this section, you can change the drilling rates and cycle, such as the number of holes per day or the penetration rate. Adjust the mucking, loading, and hauling cycle. Adjust the pump and mixer horsepower in addition to the pipe price. Determine the total amount of air required for both workers and equipment. Check the equipment purchase for primary stopes, operations, and development. Adjust the number of required workforce or salaried staff for up to 27 different roles. The last section is the report. Under this section, you can check the operating cost, including supplies, hourly labor, salaried labor, equipment operators, and miscellaneous expenses. Review capital costs such as equipment purchases, pre-production development, surface facilities, working capital, engineering management, and contingency. Change this sequence to see the operating cost for different sequences or the sustaining capital costs. Examine the operating costs in detail, such as supply costs like explosives and drill bits, hourly labor costs like stope miners and backfill plant operators, salaried labor costs like managers and engineers, and also equipment operating costs. Take a look at the capital equipment purchase schedule, which shows the number of equipment items that need to be added or replaced each year, along with the required capital expenditure. Display all development capital costs, such as adits and ore passes, and switch between total cost and cost per foot. This section also includes surface facilities, such as mine offices and surface shops. Access the detailed report, which includes all critical information about your project, such as development openings and their cost, daily supply requirements, and unit operating cost distribution for all the phases. You can also export all the information to the Excel. Thank you for your attention during this demonstration. Please feel free to reach out with any questions.